Okay, number 15. When I have an equation, can I clear the fractions? Yes, only when you have an equation. Okay? The only way I can clear fractions is to know what factors are in my denominator. So I have one factor of x minus 5. How do I determine what two binomials multiply to x squared minus 3x minus 10? What do I have to do with this? Factor it. So we're going to keep the first fraction the same and factor the denominator of my second fraction. So let's use the short method because my a value is 1. So I know that x times x is x squared. What numbers multiply to give you negative 10 and add to give you negative 3? Negative 5 and positive 2. Negative 5 times positive 2 is negative 10. And negative 5 plus 2 is negative 3. Did you get it? Okay. Now, how do I start clearing the fractions? Multiply every single term by the factors in my denominator, starting with x minus 5. It doesn't matter which one you start with. We're just starting with the one that I saw first, which was on the left. All right, so x minus 5 over x minus 5 reduces to 1. So I'm left with 1 times 2 is 2. Or I'm just left with a 2. X minus 5 over x minus 5 reduces as well. And I'm left with 10 over x plus 2. What is 1 times x minus 5? X minus 5. You could distribute the 1, but you know 1 that times anything is just whatever you multiplied by. Now what am I going to multiply everything by? X plus 2, my second denominator factor. Now, because I'm multiplying by x plus 2, I am multiplying that entire right side by x plus 2. So make sure you can leave x minus 5 in parentheses from the beginning, or you need to put it in. If you're doing a binomial times a binomial, each of them have to be in parentheses. So now my x plus 2's reduce, and that leaves me with 2 times x plus 2. What's 2 times x plus 2? 2x plus 4. After that, I'm going to add 10 because everything else reduced. And on the right side, I have x minus 5 times x plus 2. How do you multiply x minus 5 times x plus 2? You can distribute each term in the first binomial to each term in the second, or you can use the area model. Either way, if you're distributing, you're doing x times x. Same thing here, x squared. Then you're doing x times 2, which is 2x. Then you're doing negative 5 times x, which is negative 5x. And then you're doing negative 5 times 2, which is negative 10. So either way, you should come up with these 4 terms. What does that give me? Okay, where else do we see x squared minus 3x minus 10? Yeah, because when we factored that denominator, I was left with x minus 5 times x plus 2, which is what we're now multiplying together. So you could have just went back to the denominator because you already know x minus 5 times x plus 2 is x squared minus 3x minus 10. All right, now I have terms on both sides. I have x squared terms, I have x terms, I have constants. What do I need to do? Add 4 and 10, like terms. I still have x squared, x, and a constant. So I can get a trinomial. What should I do? Yeah, because if I have a trinomial, I want it equal to 0, so we're going to move the 2x and the 14 by subtracting both of them to the other side. Why do I want my trinomial equal to 0? If you have a trinomial equal to 0, then you can factor it and set each of the factors equal to 0 to solve. But you can only do that if your trinomial is equal to 0. Otherwise, you don't know what to set it equal to. So when I factor this, what does it factor to? Good. So x times x is x squared. And then we want to multiply to negative 24 and add to negative 5. So I heard that negative 8 and positive 3 would multiply to negative 24 and add to negative 5. Is that correct? Yep. What are these two terms multiplied together equal to? Good, x squared minus 5x minus 24. And that is also equal to 0, right? So if I have two factors that are equal to 0 when they're multiplied together, then I can set each of them equal to 0 to solve for x. X equals 8 and negative 3. Now, before I write those down as my two solutions, I need to check my extraneous solutions. So my excluded values are the values of x that would make my denominator equal to 0. So let's start right here. What would make my denominator equal to 0 in my first fraction? 5. So that means x cannot be equal to 5. Then in my second fraction, it's easiest to see the denominator in the factored form. So what would I plug in for x for these two values? 5 and negative 2. We already have the 5, so then we just need the negative 2. Are there any other denominators other than x minus 5 and x plus 2? No. So those are my only two excluded values. Does that mean I have to cross off one of these two? No, neither of them are 5 or negative 2, so I have two solutions here, 8 and negative 3. Okay, going down to 16. We're just simplifying on 16. How can we tell if we can simplify a rational expression? Or how do we simplify rational expressions? What do we have to do to them first? Factor them. Factor completely. That's the first thing to do. So we're going to start with the numerator. What factors out of my numerator? 5, and I'm left with x squared minus 4. So that's a greatest common factor. That's one way to factor. We're going to do greatest common factor in the denominator as well. What's my greatest common factor there? X. So I'm left with x squared plus 5x plus 6. But I can still factor each of these more. How do you factor? What method do you use to factor x squared minus 4? Difference of perfect squares. So that factors to what? Good. X plus 2, x minus 2, or x minus 2, x plus 2. Doesn't matter. Either way. Please make sure you're not putting x minus 4 and x plus 4. That's a big mistake, or a common mistake, because we're just like factoring, I don't know, too quickly. You want to make sure negative 2 times positive 2 equals negative 4. All right, we're also going to factor this trinomial right here. And because the a value is 1, we're going to use guess and check. So x times x, what multiplies to 6 and adds to 5? Positive 2 and positive 3. So we'll check that. 3 times 2 is 6. And then 3x plus 2x is 5x. So that works. What simplifies? The x plus 2. Anything else? Nope. Now, you can multiply these back together, or you can leave it in factored form. I'm okay if you leave it in factored form. But we also need to find our exclusions. Now, why is my final answer not x equals a number? Good. There's no equal sign when I start. It's an expression that I'm simplifying. Simplifying is different than solving. Solving would be find what x equals. And you have to have an equation in order to solve. Simplifying is just making it as simple as possible. What x values can I not have for my denominator? Negative 3.
2.
Negative 2. Make sure that's x plus 2, so you would plug in a negative 2. Anything else?
2.
0. So if I plug in 0 here, I get 0 times 3 times 2, which would be 0, right? So, positive 2, can I have an x value of positive 2? Yes. If I plug in 2, that'd be 2 times 5 times 4. 2 times 5 times 4 does not make my denominator equal to 0. In the numerator, do I care if my numerator is equal to 0? No. 0 out of a number, as long as it's not 0, 0 out of 7 is 0. 0 out of 100 is 0. 0 is okay to have in your numerator, just not in your denominator. So then, for this part of 16, I'm just going to draw an arrow because I don't have room to write it up there. But you get 5 times x minus 2 times x plus 3. Please do your best to write all your answers on the line if you have room to do so. Okay. 17 and 18 are two of the word problems like that will be on the test. There are a couple word problems, like 2 or 3 on the test. So we need to talk about rational expressions. Usually when you have a rational expression equation, we're talking about a rate, meaning rate per person, meaning average cost per person, or a rate meaning time, like speed is a rate. You know, you have like how many, let's see, how long does it take the fountain to drain? You're talking about how many, I don't know, an entire fountain per hour, how much of the fountain per hour can drain. So we're talking about rates the entire time. So let's start with our first rate. So in the middle of an outdoor shopping center sits a large fountain. With only valve number 1 open, the fountain will take 5.5 hours to drain. So the rate for that is 1 over 5.5 or 5.5 times the amount of time. Because if you multiplied by the entire amount of time, you would get a 1. And what does the 1 represent? 1 whole fountain drained. So 1 whole. It's easier to see with the 4. So if it says it takes for valve 2, it takes 4 hours to drain the entire fountain. How much of the fountain is drained per hour? For each hour, a quarter of it is drained, because it takes 4 total hours. So that's 1/4 per hour, and then if you were to multiply it by 4, it'd be 1 full fountain. Okay, and then why are we adding these together?
The question's on play.
Yeah, question says both valves are open now. So you have a rate of 1 times the rate of another, or added to a rate of another, but the time remains the same. So as 1 hour passes, then we'd have how much of the fountain drained? Well, it would be, let's see, 1 over 5.5 plus 1 over 4, and we would solve from that. But we don't want to know as 1 hour passes. We want to solve for the entire fountain draining. So you add these together and set it equal to an empty fountain, which would be 1 full fountain is drained. So again, these are rates. You're doing how much per hour. And this is 1 over 5.5 per hour. 1/4 per hour equals 1 whole fountain. Now we can start to rewrite this and multiply by t, our time divided by 4. And how do I get rid of the denominators? It's an equation, so can I clear the fractions? Yeah, what do I multiply by? How do you clear fractions? You multiply by the denominator. So you can start with 4 if you would like. And that gives you 4t over 5.5 plus 4 over 4 reduces to t. And 1 times 4 is 4. Now what do I multiply by to clear the other fraction? 5.5.
For the beginning part, why would you multiply by t?
Right here?
Yeah.
Because it's a rate times the amount of time. So like this 1/4 t, if 1 hour passes, 1/4 of the fountain is drained if this is all on its own. If 2 hours pass, 2/4, which is 1/2 of the fountain is drained. If 4 hours pass, the whole fountain is drained based off of this one rate. So you have to multiply by the time in order to determine how much of the fountain is drained. And then from here to here, you're just multiplying 1/4 times t. So 1/4 times t over 1 is t over 4. All right. 5.5 and 5.5 reduce because anything over itself equals 1. So I get 4t plus 5.5t equals what? 22. Very good. What's 4t plus 5.5t? 9.5t. What do I do now? Divide by 9.5. Let's see. If you want to, because you won't have a calculator on your test. If you want to multiply both of these to get a fraction, what would I multiply my denominator by so I don't have a decimal anymore? 10. So I multiply each of these by 10. I get 220 over 95. You could also multiply both of them by 2, right? Yes. So if I multiply by 2 instead, what is 19.5 times 2? 9.5 plus 9.5, or 9.5 times 2 would be 19. What's 22 times 2? So this is 44 over 19 hours. Yeah, if you multiply this by 2, it's the same as adding it to itself. Right?
Oh, yeah, I know that.
3 times 2 is 6. 3 plus 3 is 6.
Why'd you, this 20 over?
So I asked what I would multiply by to not get a decimal anymore. And you can multiply by 10, but this would have to be reduced. So if you could want to multiply by 10 and then divide each of them by 5, it'd be the same as multiplying by 2.
So just.
Yeah. Yeah, if you wanna do long division on your paper and leave it as a decimal, but you just won't have a calculator on your test. So you need to remember that yes, you may leave it as a decimal, but you have to show your long division on your test. All right. Questions? You guys have a question?
We can use non-scientific, right, on the test?
Mm-hmm. Yeah, non-scientific is fine. If you have your own. All right. Actually, maybe not. I'm fine if you use. You can use a non-scientific calculator. What? We'll talk about that at the end, after the video. Okay. All right. Number 18. An initial group of players, X, decided to buy their coach a $180 gift. So I have $180 being split between X amount of people initially. So if you talk about a cost per person, what's that called? Average cost. Okay, so if we split the entire amount by X amount of people, the average cost is initially 180 divided by the number of people. But then 4 more players decide to join the group, and what happens to the average cost? Decreases by 12. So you're going to take the average cost and decrease it by 12. This is a cost. This is a cost. And then your new cost is going to be the same total divided by how many people?
4.
So we had initial group of X, and now we have 4 people?
So X plus 4.
4 more people, so X plus 4. That means 4 more people than what we originally had. So, average cost per person decreases by 12, and you have a new average cost for a new amount of people. That's what this means. Questions about setting this up? Well, now we're going to solve it. So, in order to solve this, I want to clear the fractions. What am I multiplying everything by? X. We'll do X plus 4 next. Either way, you can start with either one, but I heard X first. So then that gives me 180 minus 12X equals 180X over X plus 4. Now what do I multiply everything by? X plus 4. Okay, what is 180 times x plus 4? 720. And negative 12x times x plus 4? Good. Make sure you know that this is a negative 12, so we're going to distribute and get negative 12x and negative 48x. Sorry, negative 12x squared and negative 48x. And on the right, we have 180x. What do you notice is on each side? So we can subtract that from each side. And write this in standard form. Now, here's a hint. Those numbers are really large and you don't have a calculator on your test. So, you're probably not going to use the quadratic formula or something like that or factor with these large of numbers. So, what do you do? Greatest common factor. What numbers are all these divisible by? 12. So I'm going to factor out a negative 12. What does that do to every one of my signs? Changes them to the opposite, and I still divide by 12. Thank you. All right, what do I do with the negative 12? Good, right now it's 12 times something equals 0. So I'm going to divide by negative 12 on each side. Does that change anything on the right-hand side? Nope. X squared plus 4x minus 60 equals 0. It's a trinomial equal to 0. What are you going to do? Factor it. What multiplies to negative 60 and adds to 4? Yep. X times x is x squared. 6 times 10 is 60. Which one needs to be negative so that my 4 is positive?
Wait.
Negative 6, positive 10. 10 minus 6 is 4. Do we get that? Okay, I have two solutions for x right here. 6 and negative 10. Which one is the correct answer? 6. Because I can't have negative 10 people. You can have negative numbers and answers in some places, but in this case, you can't have negative 10 people. Okay, go ahead and flip to the other side. All right. On problems like number 19, it is a procedure problem, meaning do you know what steps to follow in order to find common denominators of rational expressions? And the first step to follow is to factor all of the what? Denominators. So my first denominator factors to x plus 2 times x minus 2 because it is a difference of squares. Okay, you'll notice that I'm writing out each of my fractions in order to show my work, and I want to get to a common denominator. So the x plus 2 matches in 2 of these. Which one's missing in x plus 2?
The x.
Good. The x. So I need, and whatever I multiply to the denominator, I have to multiply to the. Good. Now, we're still missing some factors.
X minus 2.
X minus 2 is missing from both of the last two terms. And now what am I missing? X. So this one has everything now, right? This one's missing
An X.
X. And this one's missing
An X.
X. So now I'm going to put the X times X minus 2 and X plus 2 times X minus 2. And what is my denominator? Good. Normally our monomial goes out in front, so I'm going to go ahead and put the X out in front. X times X plus 2 times X minus 2. Or X times X minus 2 times X plus 2. Either way is fine. Yeah. How'd I get what? So this first fraction was missing an X in the denominator because this one on the very right had one, right? So if I have to multiply it to make these denominators the same, then you also have to multiply it to the numerator. So do you see how we multiplied this last one by X plus 2 and X minus 2? This first fraction already had those, but it didn't have this X. So I need to multiply it to the denominator. And these are equivalent fractions, so in order to make an equivalent fraction, you also have to multiply it to the numerator. It would be like saying if you had 1/6 and 2/3, you're multiplying this fraction by whatever factors are missing, which is 2. I have to multiply this by 2, which means I also have to multiply the numerator by 2 in order to do 1/6 plus 4/6 and then add straight across. That's what we're doing here, but with polynomials. Yeah. All right, number 20. Solve each equation algebraically, and then at the bottom of the page, mark with an X or a check mark whether each equation has no real solution, one real solution, two real solutions, or infinitely many real solutions. So starting with the first fraction, what are we going to multiply everything by? Or first equation, sorry. First equation, what do I multiply everything by? 2. The 2's reduce, and I'm left with X equals -8 over X plus 6. What do I multiply everything by now?
X plus 6.
X plus 6. What is X times X plus 6?
Shouldn't the X plus 6 be multiplied by 2?
What X plus 6? I multiplied this fraction by 2, and I did -4 times 2 is 8.
Oh, so you don't have to multiply the X plus 6 by 2?
No, because we're clearing fractions. We're not making, so up here we were making equivalent fractions because I didn't have an equation. It's an expression. This one, we're clearing fractions. So when you clear fractions, you're multiplying the number to the other side, which means you only multiply it in your numerator. It's like multiplying by 2 over 1. Okay, what's X times X plus 6? X squared plus 6X. X plus 6 over X plus 6 reduces. What should I do with that 8? Add it to the other side so that I have a trinomial. And then you factor it. X times X is X squared. What multiplies to 8 and adds to 6? 4 and 2. Good. X equals and negative 2. Let's talk about our extraneous solutions. What can x not be equal to?
-6.
Negative 6. Is that one of my solutions that I got?
No.
No. So this problem, will I cross anything off?
Nope.
No. So 20A has
2 solutions.
2 real solutions. 20B. What am I going to multiply each side by?
It's -3. X minus 3.
X minus 3. That reduces in my first fraction. Oh, so I shouldn't have a fraction anymore. X minus 3 over x minus 3 is 1. So x equals 5 times x minus 3 over x plus 5. What do I multiply everything by now?
X plus 5.
X plus 5. Alright, x plus 5 over x plus 5 reduces. What should I do now?
Distribute.
Distribute. And I get x squared plus 5x. 5x minus 15. What now? Good. Subtract 5x. Add 15. 5x minus 5x is 0. Negative 15 plus 15 is 0. X squared, oops. Negative 5x minus 5x is also 0. So I get x squared plus 15 equals 0. How do I solve this? How do I solve for x? Subtract 15. I get x squared equals negative 15. What do I do now? Square root. So plus or minus the square root. X is equal to plus or minus I root 15. How many real solutions do you have? None. Those are imaginary solutions, so you have no real solutions for 20B.